Hello class, this is the third lecture for our IS 106. Today we will talk about the second chapter, but before that, let me summarize what we discussed in the first chapter. In short, what is business statistics, or what is statistics in general? In chapter 1, the two areas of statistics, the descriptive statistics and the inferential statistics, are introduced to set the stage for what is coming in the next chapters. Descriptive statistics includes visual tools such as charts and graphs, and also the numerical measures such as the arithmetic average, the mean, median, mode. The role of descriptive statistics is to describe data and help transform data into usable information, while inferential techniques are those that allow decision makers to draw conclusions about a large body of data by examining a smaller subset of those data, the sample. Two areas of inference are estimation and hypothesis testing. They are described. Then, before data can be analyzed using business statistics or statistics in general, statistics techniques, the data must be collected. The types of data collection reviewed are experiments, telephone surveys, written questionnaires, and direct observation. Of course, personal interviews. Data collection issues such as interviewer bias, non-response bias, selection bias, observer bias, and measurement error are also part of Chapter 1, although some of these were not covered very much. And also the concepts of internal validity as well as external validity were mentioned. The important concepts of population and sample are defined, and examples of each are provided. Because many statistical applications involve samples, emphasis is placed on how to select samples. Two main sampling categories are presented: non-statistical sampling and statistical sampling. The focus is on statistical sampling, and 4 statistical sampling methods were discussed. One is the simple random sampling, stratified random sampling, cluster sampling, and the systematic random sampling. This section discusses various ways in which data are classified. For example, data can be classified as being either quantitative or qualitative. Data can also be cross-sectional or time series. Another way to classify data is by the level of measurement. There are 4 levels from lowest to highest: the nominal, ordinal, interval, and ratio data. Knowing the type of data you have is very important, as you will see in Chapter 2. Now, let's go to Chapter 2. Graphs, charts, and tables describing your data. After completing this chapter, chapter 2, you should be able to construct a frequency distribution both manually and with the use of a computer. Construct and interpret a histogram. Create and interpret bar charts, pie charts, and stem and leaf diagrams. And present and interpret data in line charts and scatter diagrams. Now, let's start about frequency distribution. What is it? A frequency distribution is a list or a table, listahan, or table, matrix, containing the values of a variable or a set of ranges within which the data belongs or falls, and the corresponding frequencies with which each value occurs, or frequencies with which data falls within each range. A frequency distribution is a way to summarize data, to make sense of it. Then the distribution condenses the raw data into a more useful form, and it allows for a quick visual interpretation of a data set. Now, frequency distribution and discrete data. What are discrete data? Discrete data are possible values that are countable, or in other words, they are whole numbers or integers as we know them probably in programming languages, as opposed to float or fractional numbers. An example here: an advertiser asks 200 customers how many days per week they read the daily newspaper. Remember, this book was written way back in 2005, and in at this time, this is about what, 15, 17 years ago, the newspaper was still very alive. Although we still have newspapers, printed newspapers around, but not very common anymore, because many of our newspapers now are in digital format. But still, they are around and you can read them. So, it is the advertiser's task to know how many customers read their newspaper, so that they could entice or they could attract more revenue from advertising business. Now we have this number of days read in a week, and the frequency 44, 24, 18, 16, 20, 22, 26, 30, a total of 200 customers. Now, example 2-2, frequency distribution for qualitative data. Vehicle ownership. The American Automobile Association recently surveyed its members about their driving habits. One question asked for the make of vehicle driven by the eldest member in the household. Make of a vehicle means it's the brand of the vehicle. The following data reflect the results for 15 of the respondents. So the make of the vehicles or brand: Ford, Chevy, Ford, Dodge, Toyota, Nissan, Chevy, Toyota, Ford, BMW, Buick, Chevy, Honda. The frequency distribution is for this qualitative variable is found as follows. And this comes in several steps. Step 1, list the possible values. You notice here they are repeating data like Ford, Toyota. You list the possible values. The possible values for the variable are BMW, Buick, Chevy, Dodge, Ford, Honda, Nissan, Toyota. Meaning, you come up with unique values out of these repeating values, because this is the result of a survey. List the possible values, list the unique values. Step 2, count the number of occurrences at each value. The frequency distribution is for car company or car model, car brand. For BMW, 1, Buick 1, Chevy 3, Dodge 1, Ford 4, Honda 1, Nissan 1, and Toyota 3, for a total of 15. Now, where's the other 5? Now, that was the frequency distribution. Here we have the relative frequency. The relative frequency tells us what proportion is in each category. Here, there are 200 respondents interviewed, and the frequency are these: 44, 24, 18, 16, 20, 22, 26, 30, for the total of 200. To get the relative frequency, you divide the frequency over the total, and the result is the relative frequency. Or if you multiply the relative frequency by 100, you'll get a percentage, which is a much easier way to think about a relative frequency. It's actually a percentage of the total population that belongs to a certain category. The proportion of total observations that are in a given category, that's the relative frequency. That's the proportion or the percentage. Relative frequency is computed by dividing the frequency in a category by the total number of observations. Katong kaganiha, actually maura to siya. Kani siya. Given in this formula. Where f sub I is the frequency of the ith value of the discrete variable, and n is the summation of k to I up to 1, or the total number of observations, and the k is the number of different values for the discrete variable. Now consider another example in which a consulting firm surveyed random samples of residents in two cities. One is Dallas, Texas, and the other is Knoxville, Tennessee. The firm is investigating the labor markets in these two communities for a client that is thinking of relocating its corporate offices to one of the two locations. The client is considering either Dallas or Knoxville. Education level of the workforce in the two cities is a key factor in making the relocation decision. The consulting firm surveyed 160 randomly selected adults in Dallas and 330 adults in Knoxville and recorded the number of years of college attended. The responses range from 0 to 8 years. Table 2.3 shows the frequency distribution for each city. Here. Frequency distributions of years of college of education. Surveyed in Dallas and Knoxville. Dallas here for 35 respondents. There are 160 respondents from Dallas. Out of 160, there were 35 who did not undergo college education, while there were 21 who at least attended first-year college or 1 year of college education, 24 for 2 years, and another 22 for 3 years. Another 31 respondents had 4-year college education, and 13 with 5-year college education. 6 respondents, 6 years in college. 5 respondents had 7 years, while 3 had 8 years. Plus, this number of years includes first year, second year, third year, fourth year, maybe fifth year if you do engineering. And this sixth year would be first year in master's, and seventh year would be second year in master's. And if you have 8 years, maybe you have enrolled first year in doctoral degree course. Now for the respondents in Knoxville, there were 187 respondents that had no college education. Maybe they were just high school graduate. And 62 had 1 year in college, 34, 2, then 19, 3, 14 respondents with 4 year in college, 7 respondents with 5 year in college, 3, 6 years, and another 4 with 7 years in college, while there was none that got up to 8 years of college education, for a total of 330 respondents. Now the same data as the first we see, but now we have the relative frequency, or the proportion of each category. 35 divided by 160, that's 0.219. If you multiply that by 100, that will be 21%, 21.9%. And 21 divided by 160 is 0.131, and so on. The same in Knoxville, frequency 187 divided by 330. That's 0.567 or 56.7%. So mas dako ang percentage sa Knoxville for respondents, or this would be adults surveyed that did not went to college. They did not went to college. So mas higher ang percentage sa college education in Dallas compared to Knoxville. Now still on frequency distribution, now this time grouping data by classes. There are many instances in which the variable of interest will be either continuous, for example like weight or length, or discrete or integers, whole numbers, but have many possible outcome, for example income and stock prices. Example here, a manufacturer of insulation randomly selects 20 winter days and records the daily high temperature. We don't have winter here, but winter is very cold time of the year in America and other temperate areas of the world. Here they have this data 24. This is daily high temperature. High na siya, I think this is in Fahrenheit, not Celsius. It says here temperature is a continuous variable because it could be measured to any degree of precision desired. So wala kay, unlike integer, discrete numbers, you can have fractional part, which makes it continuous. Now, still grouping data by classes. Sort raw data in ascending order. Katong yan temperature kaganiha, this temperature that they obtained for 20 winter days were not sorted. I suppose this was recorded 24 for the first of the 20 days, then second 35, but for statistical purposes we need to sort from lowest to highest, or you could also do it from highest down to lowest. Then find the range. The range of your data is the highest number, the maximum number, minus the lowest number. The highest is 58, the lowest is 12. So 58 minus 12 equals 46. That's the range of your data. Select number of classes. 5, usually between 5 and 20. Why 5? It depends on the researcher really, and his or her experiences. Sometimes it could be 6 or 7 or 8, or as it says here, between 5 to 20, depending on the volume of data. Then compute class with 10. Then round off. Class with unsa ka lapad ang class. Then determine class boundaries. The easiest would be by 10, 20, 30, 40, 50. But you could also do it other ways by 5, 10, 15, 20, 25. Depending on, again, the amount of data. Then count observations and assign to classes. Class would be something like this. Class 1 might be 10, but under 20, meaning that's 10 up to 19. Then 20 up to 29, 30 up to 39, 40 up to 49, 50 up to 59. Then you count how many of these data falls within this range, this class. For 10 to 20 or 19, I can count 1, 2, 3. That's here. That's why we put 3 here. For 20 to 29, it should be 1, 2, 3, 4, 5, 6. Put here 6. For class 30 to 39, 1, 2, 3, 4, 5. That's 5. For class 40 to 49, 1, 2, 3, 4. That's 4. For 50 to 59, there's only 2. For a total of 20. And we take the relative frequency or the proportion of these frequencies in each class based on the total number of population. 3 divided by 20, that will be 0.15, and 6 divided by 20 is 0.3, 5 divided by 20 is 0.25, 4 divided by 20 is 0.2, 2 divided by 20 is 0.10. Class, the total of this relative frequency must always be 1.0. No more, no less. Because if it is not 1.0, that means something went missing. Something went unaccounted for. It's always the whole proportion, when you add all the relative frequencies, it should add up to 1.0. Now, let's talk about histograms. What are histograms? The classes or intervals are shown on the horizontal axis in histograms. And frequency is measured on the vertical axis. Horizontal is like that, diba? And vertical is like that. Bars of the appropriate heights can be used to represent the number of observations within each class. Such a graph is called a histogram. This is an example of a histogram from our sorted data of temperatures. And the frequency frequency between 10 to 20 is 3, and we draw a vertical bar graph to represent 3, and for 20 to 29 that was 6, we draw 6, and so on. So this is how the histogram looks like. Now, questions for grouping data into classes. How wide should each interval be? Or how many classes should be used? And how should the endpoints of intervals be determined? This is often answered by trial and error, subject to user judgment, subject to the researcher. There is no hard and fast rule for this. Then the goal is to create a distribution that is neither too jagged or too blocky. O dili kayo blocky is taba, jagged is slim. The goal is to appropriately show the pattern of variation in the data. Here, how many class intervals? Here, when it is many, that could result to narrow class intervals like this. Gagmay. Kung daghan class intervals. Ni-plot nimo, gagmay sila, slim. It may yield a very jagged distribution with gaps from empty classes like this. Walay sulod. And it do not look very good. It can give a poor indication of how frequency varies across classes. While if it is too few, the opposite would happen. It may compress variation too much and yield a blocky distribution, tambok ra po kayo. And it can obscure important patterns of variation. So dili ni noon kayo nimo makita ang variation. Yung mga diferensya kung lapad ra kayo ang imuhang class interval. In general rules or general guidelines, the number of data points versus number of classes. If you have under 50 data, you should have only around 5 to 7 number of classes or intervals. If you have 50 to 100, maybe you can have 6 to 10, or 50 to under 100, 100 to under 250, maybe you could have 7 up to 12. And if you have your data is over 250, you could have from 10 to 20. So class width, ang kabaga, kalapad, can be typically be reduced as the number of observations increases. And distributions with numerous observations are more likely to be smooth and have gaps filled since data are plentiful. Kung daghan ang imong observations, ang imong data, daghan imong population, it is more likely your chart is more likely to be smooth and gaps avoided. So remember this class. under 50, 5 to 7, 50 to under 100, 6 to 10, 100 to 250 data, 7 to 12 classes. While if you have over 250, you could have from 10 to 20 number of classes. Now still with class width, the class width is the distance between the lowest possible value and the highest possible value for a frequency class. The minimum class width is given by W, this width, the largest value minus the smallest value over a number of classes. Now, we have an example here, the emergency response communication links. Emergency response. We have here our disaster risk reduction management. I think it's now everywhere in every LGU. The agency of the government that is responsible to respond quickly to emergency in case of disasters. Recently we had disasters like Typhoon Odette, which destroyed so many houses and buildings and destroyed plantations, coconut plantations, tree plantations, banana plantations throughout Caraga and in Leyte and Cebu, as well as Bohol. Emergency response communication links is very important. Here in our example, one of the major efforts that was in the U.S. Office of Homeland Security, which I mentioned, is we have our version here, the National Disaster Risk Reduction Council, and the equivalent in the local municipalities and cities, risk reduction disaster management councils. This is in the U.S. Homeland Security, they call it, has been to improve the communication between emergency responders like the police and fire departments. In case of emergency like disasters, it is very important that the emergency responders can respond very quickly and that they are connected very quickly also. The communications have been hampered by problems involving linking divergent radio and computer systems, as well as communication protocols. While most cities have recognized the problem and made efforts to solve it, the Homeland Security recently funded practice exercises in 72 cities of different sizes throughout the United States. The resulting data already sorted but representing seconds. This is in seconds. These numbers are in seconds before the systems were linked. This is number of seconds before a system is linked to one another. I suppose this is between cities. The police, say the police and fire departments were linked to each other in case of emergency. These are given in seconds, already sorted. The lowest is 35 seconds, the highest is 1,492 seconds. How many minutes is that? That's a long time to respond for an emergency. Now we can do this in several steps. Step 1, group the data into classes. The number of classes is arbitrary, as we discussed earlier. It depends on the the researcher wants and his or her experiences. Is arbitrary but typically will be between 5 and 20 depending on the volume of data. In this example, we have n equals 72 data items. Using the 2 to the power of k, where it is greater than or equal to n guideline, we get k equals 7 classes. In step 2, determine the class width, where width w equals the largest value minus the smallest value divided by the number of classes. So in that case, the highest value was 1492 minus the lowest value, which is 35 seconds. Let's have a look again. The highest value is 1492 seconds. The lowest value is only 35 seconds. So we have 208.1429. But again here, it is rounded off to a more convenient number for counting. It could have 210 or 209, but they think that 222 is more convenient for counting. Note we have rounded the class width up from the minimum required value of 208.1429 to the more convenient value of 222. Then step 3, define the class boundaries. Again, class, why 222 instead of 208 plus something? Again, experience will tell you that, and it's like coming up with the number of classes. It comes with experience. Step 3, define the class boundaries. So 0, the researcher have decided 225 instead of 208 or 209. So from 0 to 0 and under 225, 225 and under 450, that's the interval is 25. So you notice this is the interval here is 225. 200, you add this, you add 225 to this, and another 225, another 225, and you get the idea. So your range actually would include a higher number than the highest data, and that's okay because that's a range. Now step 4, determine the class frequency for each class. Now you count how many observations belong from 0 to 225, and you can easily count that from this data once you have sorted, just like what we did earlier. You count how many data that falls to a certain class. This frequency distribution shows that most cities took between 450 and 1,350 seconds, or in minutes, the 7.5 and 22.5 minutes to link their communications systems during disaster, which I think this long would also be a disaster, because if it is fire, then fire would have consumed so much, would have inflicted so much damage already after 20 minutes of fire. Now here's a drill. Blockbuster is one of the largest video rental and sales companies in the United States. Its stores rent and sell DVD products. You should have seen a DVD, at least on picture maybe. Remember that this book was written in 2005, about 17 years ago, and at this time DVD or CDs were very popular form of storage. Movies and music were stored in DVDs and compact CDs, and they are either sold or rented. Recently, a district manager for Blockbuster in Arkansas conducted a survey of customers in her district. Among the questions asked on the written survey was, how many DVD movies do you own? In case of they buy. A total of 230 people completed the survey. So table 2.6 shows the responses to the DVD ownership question. These data are discrete or whole numbers, quantitative data. Values ranges from 0 to 30. The manager is interested in transforming these data into useful information by constructing a frequency distribution, which is shown in table 2.7. One approach where the possible values for the number of DVD movies owned is listed from 0 to 30. Although this frequency distribution is a step forward in transforming the data into information, because of the large number of possible values for DVD movies owned, the 230 observations are spread over a large range, making analysis difficult. In this case, the manager might consider forming a grouped data frequency distribution by organizing the possible number of DVD movies owned into discrete categories or classes. Here's the data. Unsorted. Libog kay siya kung dili siya sorted. Now from that DVD movies owned by from the Blockbuster survey, they produced this. They sorted this from lowest to highest, and then determine class intervals, and then class frequency, and these are the class from 0 to 5. Those respondents who have 0 to 5, or 0 to below 5, 0 to 4, then 5 to 9, 10 to 15 to 14, 15 to 20, 20 to 15 to 19, 20 to 24, 25 to 29. You notice there was only one respondent who owned who belonged to this class from 25 to 29. 12 for 20 to 24. 12 persons owned at least 20 DVDs. or movies on DVD. And there were 84 of the respondents said that they have at most 4 DVD movies. Now, histograms can be easily constructed using Excel. Using Excel. This is a continuation of the emergency response. I don't know why they jump from one example to the other. Now, the Director of Emergency Responses in Montreal, this is a different one, Canada, and the other one was from the US, is interested in analyzing the time needed for response teams to reach their destinations in emergency situations after leaving their stations. She has acquired the response times for 1,220 calls last month or the other month. To develop the frequency histogram, perform the following steps. Construct a frequency distribution. Because response time is a continuous variable measured in seconds, the data should be broken down into classes, and the steps given in example 2.3 and the previous one that we discussed should be used. And the following frequency distribution with 10 classes was developed. Why 10? Well, it's arbitrary. It depends on who made the decision. It could also be 7. Here is 10 classes, 0 to 29 or under 30, 30 to 59, 60 to 89, 90 to 119, 120 to 114, 120 to 149, 150 to 179, then 180 to 210, 209, 210 to 239, 240 to 269, and the last class is 270 and under 70. And these are the frequency distributions, number of minutes that took the responders to get to their destination. Then construct the axis for the histogram. The horizontal axis will be response time, horizontal, kanang nakahigda. And the vertical, kanang nagana, the skillet axis will be frequency. In step 6, construct bars with heights corresponding to the frequency of each class. Now, there's an issue with Excel. If you use Excel to construct a histogram, as indicated in the previous instruction, figure 2.5, the initial graph will have gaps between the bars. Because histograms illustrate the distribution of data across the range of all possible values for the quantitative variable, histograms do not have gaps. In reality, histograms should not have gaps. But it might, if you use Excel, it might appear that histograms have gaps. Therefore, to get the proper histogram format, you need to close these gaps by setting the gap width to 0 as indicated in the Excel instructions shown in figure 2.5. This is what they have from the data given earlier from the emergency response team. How many seconds the responder get to their destination from the time they leave their station. From 0 to 300 minutes. Frequency, number of responders, and number of seconds. Now, here's a drill class that you may need to perform in your one of your laboratory exercises. This one is about Burger King. I'm not sure if there is a Burger King in Butuan, but in larger cities there are Burger Kings. This is food house, a restaurant of some sort, like Jollibee or McDonald's. Burger King is one of the largest fast food franchise operations in the world. Recently, the district manager for Burger King in Las Vegas conducted a study in which she selected a random sample of sales receipts. She was interested in the number of line items on the receipts. Pila ka book entry sa receipts. For instance, if a customer ordered 2 1/4 pound hamburgers, tinimbang ng ilang hamburgers, then 1 side of fries and 2 soft drinks, the number of line items would be considered to be 5, because 2 hamburgers, 1 fries, and 2 soft drinks. That's 5. The following data were observed. This is from receipt, and the number from receipt. This one here. As is unsorted, that this data looks doesn't as if they don't mean anything. Now, letter A, what you need to do, develop a frequency distribution for these data. As the discussions that we had already, you need to sort this before you can develop a frequency distribution to make sense out of this data. You have to sort from lowest to highest, or highest down to lowest. Then you can develop a frequency distribution, then discuss briefly what the frequency distribution tells you about these sample data. Meaning, interpret what it means once you have created the frequency distribution from this data. Interpret what it means. Then B, based on the results in part A, result any, construct a frequency histogram for these sample data. And this would be all for this lecture class. We'll stop here, and just remember you will execute this drill, this exercise, in your next laboratory. But before this, you will have this would be your second laboratory exercise. There is one I prepared for you, um, that comes from the first lecture, and class, you need to input this. I will give you instruction when it comes. For now, um, um, that will be all for now, and see you during the next lecture.